Hi everyone, my name is Alicia Panzarella and this is the Module 1 video that's going to look at how do students learn and how are we going to apply that to STEM. So a little bit about myself from the professional level is that I am a Millersville grad. I am a physics teacher, or I should say I'm the physics teacher over at Eastern York High School, and I am the newly appointed assistant boys volleyball coach. So very excited to start that new venture in the fall. From the personal level, I am a fan of fitness, but I'm more so a fan of traveling and anything that deals with the outdoors. So this nice new weather has been great. Now, a little bit more focused as to why I'm pursuing STEM. I will admit that when I chose my master's program, I said, hey, I'm a science teacher. This makes sense. However, the more I go through the courses within this program, the more I'm realizing the value behind the ideals and the principles that come with STEM. It is so much more than just saying, I teach science. So with that, looking at how students learn, we know that there are kind of three fundamental principles behind what is needed for good learning. The first thing is that we have to engage students' preconceptions and misconceptions. We need that to come to their conscious level and say, okay, you have this, but how are we going to now take this, build on it, and develop a much more rich foundation that is involved with both the factual and conceptual realm of knowledge. It can't just be one or the other. They have to see the marriage between the two. Now, this knowledge cannot just come from the teacher lecturing. Gone are the days where we are just this fountain of knowledge. The students are now the scientists. The students are engaged in the inquiry and the discovery process, and all the while they have a little bit of imagination and creativity. But what they need from there is that metacognition stage. They need to be able to say, this is my thinking and learning now. This is where it was, but this is where I want to be. Now, as far as barriers, I'm sure all of us could jump on the same train and say, oh, we don't have enough time, resources, I got to hit the keystones, I got to get the AP exam. But everybody has that. If we're looking at what are the barriers to learning science, we have to say, when we look at this student in front of us, what do we want them to get from our class? And it's not just, I want them to know formulas and theorems. I want them to be able to problem solve, critically think, be able to analyze multiple different pieces of data, and realistically learn all of these different skills that's going to help them grow into their potential. And I think there are three major barriers with that. One being that students and adults think they know how things work. And when you think you know what's going on, you have a tendency to resist any change. With that comes the everyday conceptions and perceptions where a student thinks that scientific knowledge is either right or wrong. And they are now so afraid to be wrong or to voice a wrong opinion or a wrong idea that it almost halts them and says, I'm not going to participate in this. So I think that is a huge barrier. And the last one I think is the media and getting students to see the difference between fact and fiction. Now, as far as my classroom, I do think I am more so the combining two or three disciplines. I would love to more so be in the transdisciplinary course figure 8.9. However, if we're looking at the tenets of teaching science, I will say that my class very much so utilizes the inquiry and discovery process. Not as much, I think, on the conceptual level that the two teachers in chapter 11 described, but very much so from the quantitative level that still has that factual and conceptual knowledge in it. Now, as far as what STEM perspective I think I align with, I will say that I wasn't a huge fan of the 9 that were provided because it still just seemed like it was here's science, here's technology, here's engineering, here's math, and sometimes they come together. I don't think STEM is just that. STEM is that inquiry, it's the design, it's the evaluation, and it's finally the application. So it's building skills and a mindset that students need in order to succeed and grow into the person that they're meant to be. I will also provide this graphic in my discussion, but I don't think STEM is just a collection of subjects. It is a mindset on both the teacher and the student.